Question 201. A few days after JencoMart migrates the user credentials database to Google Cloud Platform and shuts down the old server, the new database server stops responding to SSH connections. It is still serving database requests to the application servers correctly. What 3 steps should you take to diagnose the problem? Choose 3. A. Delete the virtual machine, VM, and disks and create a new one. B. Delete the instance, attach the disk to a new VM, and investigate. C. Take a snapshot of the disk and connect to a new machine to investigate. D. Check inbound firewall rules for the network the machine is connected to. E. Connect the machine to another network with very simple firewall rules and investigate. F. Print the serial console output for the instance for troubleshooting, activate the interactive console, and investigate. The best 3 steps to diagnose the problem are C, D, and F. Correct options and explanation. 1. Option C. Take a snapshot of the disk and connect to a new machine to investigate. Since the database server is still running and serving requests, the issue is likely networking, SSH configuration, or a corrupted SSH key rather than a complete VM failure. A snapshot allows investigation without risking further damage. Mounting the disk on another machine lets you check logs, permissions, and SSH configurations safely. 2. Option D. Check inbound firewall rules for the network the machine is connected to. A common reason for losing SSH access is a firewall rule blocking SSH, port 22. Google Cloud's VPC firewall rules might have been modified after migration, preventing SSH connections. Verifying firewall rules ensures the instance is reachable over SSH. 3. Option F. Print the serial console output for the instance for troubleshooting, activate the interactive console, and investigate. The serial console provides system logs even when SSH is not working. This helps diagnose boot issues, SSH daemon failures, or incorrect configurations. Enabling the interactive console may allow direct access to fix the issue without modifying the instance externally. Incorrect options and why they should be avoided. Option A. Delete the VM and disks and create a new one. Too destructive, this would erase critical logs needed for troubleshooting. The database is still running, meaning the instance itself is not fully broken. Option B. Delete the instance, attach the disk to a new VM, and investigate. Partially correct, but deleting the instance immediately is unnecessary. Instead, take a snapshot first, option C, before attaching the disk elsewhere. Option E. Connect the machine to another network with very simple firewall rules and investigate. Not practical, changing the network might cause downtime and break existing application connectivity. Checking current firewall rules, option D, is a safer approach. Conclusion. The best approach is to analyze the problem before making destructive changes. Start with serial console logs, F. Check firewall rules, D. And inspect the disk safely, C. To restore SSH access efficiently. Question 202. JencoMart has decided to migrate user profile storage to Google Cloud Datastore and the application servers to Google Compute Engine, GCE. During the migration, the existing infrastructure will need access to Datastore to upload the data. What service account key management strategy should you recommend? A. Provision service account keys for the on-premises infrastructure and for the GCE virtual machines, VMs. B. Authenticate the on-premises infrastructure with a user account and provision service account keys for the VMs. C. Provision service account keys for the on-premises infrastructure and use Google Cloud Platform, GCP, managed keys for the VMs. D. Deploy a custom authentication service on GCE Google Kubernetes Engine, GKE, for the on-premises infrastructure and use GCP managed keys for the VMs. The best answer is option C. Provision service account keys for the on-premises infrastructure and use Google Cloud Platform, GCP, managed keys for the VMs. Explanation. 1. On-premises infrastructure requires access to Datastore. Since on-premises systems cannot use Google's managed identity services, like IAM with Compute Engine default service accounts, they must authenticate using service account keys. Provisioning a service account key and storing it securely allows on-premises systems to access Datastore. 2. GCE virtual machines, VMs, should use Google-managed keys. GCE instances can use Google Cloud's built-in service accounts with IAM permissions instead of manually managed keys. Google-managed keys rotate automatically, reducing security risks. Analysis of other options. Option A. Provision service account keys for both on-premises and GCE VMs. Incorrect because GCE VMs should use Google-managed keys rather than manually managed service account keys. Manually handling keys for GCE increases security risks, example, leaked or compromised keys. Option B. Authenticate on-prem with a user account and provision service account keys for VMs. Incorrect because user accounts are not recommended for service-to-service authentication. Service accounts should be used instead, since user accounts can be disabled, rotated, or require human intervention. Option D. Deploy a custom authentication service on GCE GKE and use GCP managed keys for VMs. Incorrect because a custom authentication service is unnecessary for this scenario. Using Google's IAM and service accounts is the best practice. Adding a custom authentication layer increases complexity and maintenance overhead. Conclusion. The most secure and manageable approach is to provision service account keys for on-premises infrastructure, since it cannot use Google's IAM directly, while using Google-managed service accounts for GCE VMs to take advantage of automatic key rotation and IAM security best practices. Option C follows Google Cloud's recommended best practices. Question 203. JencoMart has built a version of their application on Google Cloud Platform that serves traffic to Asia. You want to measure success against their business and technical goals. Which metrics should you track? A. Error rates for requests from Asia. B. Latency difference between US and Asia. C. Total visits, error rates, and latency from Asia. D. Total visits and average latency for users from Asia. E. Are the number of character sets present in the database. The best answer is option C. Total visits, error rates, and latency from Asia. Explanation. JencoMart's goal is to measure business and technical success for their application serving traffic to Asia. 1. Business metrics. Total visits measures user engagement and adoption of the application in Asia. If traffic is low, it could indicate issues with marketing, accessibility, or user experience. 2. Technical metrics. Error rates measures system reliability and stability. A high error rate suggests issues in application performance, network connectivity, or infrastructure stability. Latency from Asia measures performance for users in the target region. High latency can degrade user experience, leading to lower engagement and revenue. Analysis of other options. Option A. Error rates for requests from Asia. Partially correct, but does not measure business success, only system reliability. Tracking error rates alone does not indicate how many users are actually accessing the service. Option B. Latency difference between US and Asia. Not sufficient, as it only focuses on a performance comparison rather than tracking success in Asia. JencoMart's priority is user experience in Asia, not a comparison with the US. Option D. Total visits and average latency for users from Asia. Partially correct, but it misses error rates, which are critical for assessing system stability. Without error tracking, issues like failed requests or system outages might go unnoticed. Option E. The number of character sets present in the database. Not relevant to measuring business or technical success. Character sets matter for localization but do not directly measure user experience or reliability. Conclusion. Tracking total visits, error rates, and latency from Asia gives a complete view of user engagement, reliability, and performance, making option C the best choice. Question 204. The migration of JencoMart's application to Google Cloud Platform, GCP, is progressing too slowly. The infrastructure is shown in the diagram. You want to maximize throughput. What are 3 potential bottlenecks? Choose 3. A. A single VPN tunnel, which limits throughput. B. A tier of Google Cloud storage that is not suited for this task. C. A copy command that is not suited to operate over long distances. D. Fewer virtual machines, VMs, in GCP than on-premises machines. E. A separate storage layer outside the VMs, which is not suited for this task. F. A complicated internet connectivity between the on-premises infrastructure and GCP. The best choices are Option A, Option C, Option F. Explanation. 1. A single VPN tunnel, which limits throughput, Option A. VPN tunnels have bandwidth limitations. A single cloud VPN tunnel provides up to 3 gigabits per second of throughput, but actual performance depends on factors like encryption overhead and network conditions. If a higher throughput is needed, multiple VPN tunnels or cloud interconnect should be used. 2. A copy command that is not suited to operate over long distances, Option C. Copy commands like SCP or RSYNC are not optimized for high latency, long-distance transfers. XUTIL MCP, parallel transfers, or storage transfer service should be used for efficiency. 3. Complicated internet connectivity between the on-premises infrastructure and GCP, Option F. If on-premises connectivity to Google Cloud is slow, unstable, or has high latency, migration performance suffers. Upgrading to dedicated interconnect or partner interconnect can improve throughput and reliability. Analysis of other options. Option B, a tier of Google Cloud storage that is not suited for this task. Unlikely to be a major bottleneck. Google Cloud storage tiers, standard, nearline, cold line, impact cost and retrieval latency, but standard storage should not slow migration. Option D, fewer virtual machines in GCP than on-premises machines. Not necessarily a bottleneck unless the workload is CPU-bound or disk I/O limited. Scaling VMs up or using preemptible VMs can help, but network transfer speed is a bigger issue. Option E, a separate storage layer outside the VMs, which is not suited for this task. Unclear impact. Cloud storage and persistent disks are optimized for cloud workloads and should not slow down migration unless misconfigured. Conclusion. The biggest migration bottlenecks are VPN tunnel limitations, inefficient copy commands, and complex internet connectivity, making options A, C, and F the best choices. Question 205. JencoMart wants to move their user profiles database to Google Cloud Platform. Which Google database should they use? A. Cloud Spanner. B. Google BigQuery. C. Google Cloud SQL. D. Google Cloud Datastore. The best choice is option D, Google Cloud Datastore. Explanation. JencoMart wants to move their user profiles database to Google Cloud. User profile data typically includes structured but flexible and semi-structured information like names, addresses, preferences, and settings. It requires scalability and low latency access, making Cloud Datastore the most suitable option. One Cloud Datastore is a NoSQL document database that is optimized for storing and retrieving user profile data at scale. 2. It offers automatic scaling, high availability, and strong consistency for most queries, ensuring fast access. 3. It supports hierarchical and flexible schema designs, making it ideal for user profiles, which can vary in structure. Analysis of other options. Option A, Cloud Spanner, is a relational database designed for global transactions and strong consistency. It is overkill for user profile storage, as profiles typically do not require strong ACID transactions across regions. Option B, BigQuery, is a data warehouse meant for analytical workloads and batch processing, not for frequent, low-latency reads and writes of user profiles. Option C, Cloud SQL, is a managed relational database, but it does not scale as well as Datastore for high-volume, flexible profile storage. Relational databases are more suited for structured data with predefined schemas, which may not be ideal for dynamic user profiles. Conclusion. For user profiles, Cloud Datastore is the best choice because it is highly scalable, flexible, and optimized for low-latency access, making it a Google-recommended database for storing such data. Question 206. You are implementing Firestore for MountGurk Games. MountGurk Games wants to give a new game programmatic access to a legacy game's Firestore database. Access should be as restricted as possible. What should you do? A. Create a service account, SA, in the legacy game's Google Cloud project, add a second SA in the new game's IAM page, and then give the organization admin role to both SAs. B. Create a service account, SA, in the legacy game's Google Cloud project, give the SA the organization admin role, and then give it the Firebase admin role in both projects. C. Create a service account, SA, in the legacy game's Google Cloud project, add this SA in the new game's IAM page, and then give it the Firebase admin role in both projects. D. Create a service account, SA, in the legacy game's Google Cloud project, give it the Firebase admin role, and then migrate the new game to the legacy game's project. The best option is option C. Create a service account, SA, in the legacy game's Google Cloud project, add this SA in the new game's IAM page, and then give it the Firebase admin role in both projects. Explanation. MountGurk Games wants programmatic access to a Firestore database from a new game, but access should be as restricted as possible. 1. Creating a service account, SA, in the legacy games project ensures that access is properly managed. 2. Adding this SA to the new game's IAM page allows the new game to authenticate and access Firestore. 3. Granting the Firebase admin role in both projects ensures it has read-write access to Firestore, which is needed for data operations. 4. This approach follows the least privilege principle, giving access only where necessary. Analysis of other options. Option A, giving organization admin to both SAs, is too broad and violates the least privilege principle. Organization admin has full control over all projects, which is unnecessary. Option B, giving organization admin to one SA and Firebase admin to both projects, is also too broad. Organization admin is a highly privileged role and is not required for Firestore access. Option D, migrating the new game to the legacy project, might work but is not practical. Projects are typically managed separately, and merging them could cause security, billing, and operational complexity. Conclusion. The most secure and practical solution is option C, as it follows Google's best practices for least privilege access while allowing the new game to interact with the legacy Firestore database. Question 207. For this question, refer to the Helicopter Racing League, HRL, case study. Your team is in charge of creating a payment card data vault for card numbers used to bill tens of thousands of viewers, merchandise consumers, and season ticket holders. You need to implement a custom card tokenization service that meets the following requirements. Asterisk, it must provide low latency at minimal cost. Asterisk, it must be able to identify duplicate credit cards and must not store plain text card numbers. Asterisk, it should support annual key rotation. Which storage approach should you adopt for your tokenization service? A. Store the card data in Secret Manager after running a query to identify duplicates. B. Encrypt the card data with a deterministic algorithm stored in Firestore using Datastore mode. C. Encrypt the card data with a deterministic algorithm and shard it across multiple memory store instances. D. Use column-level encryption to store the data in Cloud SQL. The best choice is option B. Encrypt the card data with a deterministic algorithm stored in Firestore using Datastore mode. Explanation. A custom card tokenization service must store securely encrypted payment card data while ensuring low latency and efficient duplicate detection at minimal cost. The optimal approach should allow fast lookups while preventing plaintext storage of card numbers. 1. Deterministic encryption allows consistent encrypted values for the same input, card number, enabling duplicate detection without storing plaintext. 2. Firestore in Datastore mode is optimized for low latency, high availability lookups at scale, making it a great choice for frequent tokenization queries. 3. Firestore Datastore mode supports annual key rotation by re-encrypting the stored values using a new key while maintaining lookup integrity. 4. Firestore offers a cost-effective, serverless NoSQL solution, minimizing operational overhead compared to relational databases like Cloud SQL. Analysis of other options. Option A. Secret Manager. Not suitable because Secret Manager is meant for managing small sensitive secrets, keys, passwords, not for storing large datasets like tokenized credit cards. Inefficient for duplicate detection due to lack of querying capabilities. Option C, Memory Store. Memory Store, Redis, is an in-memory store, optimized for caching, not for persistent storage of sensitive data. Sharding encrypted values across multiple instances is unnecessary complexity without clear benefits. Option D, Cloud SQL with column-level encryption. Cloud SQL is not designed for large-scale, high-read low-latency lookups like Firestore Datastore. Column-level encryption does not inherently support deterministic encryption for duplicate detection. Conclusion. Firestore in Datastore mode with deterministic encryption offers the best balance of low-latency lookups, cost efficiency, duplicate detection, and security compliance. It aligns with Google recommended best practices for secure storage of tokenized payment card data while supporting annual key rotation. Question 208. For this question, refer to the Helicopter Racing League, HRL, case study. Recently, HRL started a new regional racing league in Cape Town, South Africa. In an effort to give customers in Cape Town a better user experience, HRL has partnered with the content delivery network provider, Fastly. HRL needs to allow traffic coming from all of the Fastly IP address ranges into their virtual private cloud network, VPC network. You are a member of the HRL security team and you need to configure the update that will allow only the Fastly IP address ranges through the external HTTPS load balancer. Which command should you use? A, B, C, D. Answer is D. AWS firewalls can be used to restrict both internal and external traffic. GCP firewall rules are varied where VPC-level firewall rules are for restricting internal traffic and Cloud Armor which gets attached to pounds is used to restrict external traffic. So due to GCP oddity, G-Cloud Compute Firewall refers to internal VPC firewall config which isn't relevant, while G-Cloud Compute Security Policies refers to Cloud Armor, which gets attached to pounds and is used to configure external firewall rules, which is relevant. Once you understand that D as the answer starts to make intuitive sense. Question 209. For this question, refer to the Helicopter Racing League, HRL, case study. The HRL development team releases a new version of their predictive capability application every Tuesday evening at 3 a.m. UTC to a repository. The security team at HRL has developed an in-house penetration test cloud function called Airwolf. The security team wants to run Airwolf against the predictive capability application as soon as it is released every Tuesday. You need to set up Airwolf to run at the recurring weekly cadence. What should you do? A. Set up cloud tasks and a cloud storage bucket that triggers a cloud function. B. Set up a cloud logging sync and a cloud storage bucket that triggers a cloud function. C. Configure the deployment job to notify a pub/sub queue that triggers a cloud function. D. Set up identity and access management, IAM, and confidential computing to trigger a cloud function. The best approach is option C. Configure the deployment job to notify a pub/sub queue that triggers a cloud function. Explanation. The Airwolf cloud function needs to run immediately after the predictive capability application is released. The best way to achieve this is to integrate it with the deployment job so that a pub/sub message is published once the deployment completes. A cloud function can be triggered by the pub/sub message, ensuring that Airwolf runs exactly when required. Other options. Option A, Cloud Tasks plus Cloud Storage. Cloud tasks are used for managing asynchronous execution, but there is no need for a task queue in this scenario. Option B, Cloud Logging plus Cloud Storage. This approach is not reliable for triggering Airwolf immediately after deployment. Option D, IAM plus Confidential Computing. IAM controls access, and confidential computing protects sensitive data, but neither helps with scheduling. Question 210. For this question, refer to the Helicopter Racing League, HRL, case study. HRL wants better prediction accuracy from their ML prediction models. They want you to use Google's AI platform so HRL can understand and interpret the predictions. What should you do? A. Use explainable AI. B. Use Vision AI. C. Use Google Cloud's Operations Suite. D. Use Jupyter Notebooks. The best approach is option A. Use explainable AI. Explanation. HRL wants to understand and interpret model predictions, which is exactly what explainable AI is designed for. It provides insights into which features contributed to a model's decision, helping HRL to analyze and improve prediction accuracy. Other options. Option B. Vision AI used for image and video analysis, not applicable to predictive models. Option C. Cloud Operations Suite useful for monitoring but not for explaining ML model predictions. Option D. Jupyter Notebooks helps in developing models but does not explain predictions in production.